This is a presentation on SurfaceArrayPro, which is the first release of class Ajiro. It's a first release to see what's the interest out there about creating patterns over alias surfaces. And like in this example, we are distributing this spherical shape module over these three alias surfaces, following them exactly. You're not only constrained to these type of geometry, but you can use all sorts of modules that you can create in Alias. Like in this case, we use the pyramidal shape. It is distributed across a different type of grid with a wavy behavior that makes it a little bit more interesting than just a regular grid. We will see these applied to different parts of the model. With different flows. These are steel cylinder, which can be used to cut the surfaces as a perforation. And again, you can use all sorts of modules for it. In this case, some sort of a class still created in Alias was used. But most importantly, it's a good tool to create patterns over multiple surfaces that create more complex shapes, which usually, even in software like Dynamo or Grasshopper, are not as straightforward to be created and require a lot of knowledge. Instead, class Ajiro tries to do that with a different spin, and we'll see that later. In the current release, the current version, class Ajiro, it's relatable to the surface array in Alias, which also places objects over surfaces. But class Ajiro gives you just much more control and is just a more powerful tool to do that similar task. And also gives you the ability to do this kind of a fading effect with much more ease than it will be possible with surface array, and in some cases I think surface array wouldn't even be possible to do. In the future, I want to grow this software to create tiling, all sorts of tiling effects with all sorts of shapes and grids, and with an easy way to control fading effects of this kind. But for now, it's just applying objects and that can be used to create perforations with some fading effect, as we have seen. But now let's crack on and see how to prepare the surfaces in Alias to be used for patterning in class Ajiro. First thing to notice is that Ajiro makes patterns only on surface strips, so aligned surfaces like those, they are aligned. And for instance, for the pattern that I had here, this pattern, I used these surfaces. So you see they are all one after the other on one line. At the moment, still doesn't support like a network of surfaces. I mean, it will accept even if they're not on a line, but class Ajiro will think of them as if they are on a line, and so the pattern will follow them as if they are on a line. Anyway, we are going to prepare those surfaces for this type of pattern. It doesn't recognize trimmed surfaces, so we will have to make them as untrimmed surfaces. But with the tools that we have in Alias, it's not a complicated job. We are getting close, so this surface is okay because it's already untrimmed. instead these two, as you see, they continue after this border, and we can use the trim convert tool from Alias to make them untrimmed. So we see he has already done it there. Now, another thing to consider is the parametrization of the surfaces. So for a good result in class Ajiro, you will need same parametrization for the flow of the surfaces. So maybe this step in the CV may create some step also in the pattern. It will probably not be noticeable at this level, but for safety, let's do it. Let's align the surfaces with the align tool. Of course, this will create some divergence from the actual model, from the actual geometry, but for just placing objects, it's okay. So now we have a continuous strip of surfaces, and we can now save them as an IGES file and be imported in class Ajiro. Okay, let's now open class Ajiro. You will see there's another window which shows the console, which helps you see the progress, for instance, when you open an IGES file, because it's still not quite as optimized as a more advanced software. But there you go, it got in 3 surfaces. Let's enlarge it. So first of all, when you press the Alt key and press the left mouse button, you can drag it and spin the model. If you press the Alt key and click on a border, you will be able to change the center of rotation. If you press Alt key and the right mouse button, you will zoom. If you press Alt key and the middle mouse button, you will pan it. When you press the X key, you get perspective, and you can also achieve it from here. But let's now start to create a grid straight away. You can see we have 2 ways to create a grid. Regular follows more the borders and the flow of the surface. The other one doesn't care about that. And we start with the regular. There's some default setting in the division. And you can see that things went a bit funny, not as we intended. And that's because of the direction of the surfaces, which we can fix with another tool that is called Swap and Reverse UV. Let's close it for now. So we should always have the red direction, which is the U direction, with the flow of the surfaces. So we need to swap those. Reverse and swap. And there you go. Now they are all flowing in the same way with the U direction along the strip. We can now reopen our grid tool, and you can see that now the flow is as we wanted it. Let's take a number of points that we think is gonna look good. This is now a rectangular grid, and we can make it a diamond grid, which is usually more interesting. And this is a uniform spaced grid, right? And that's our base to create a pattern. You can use the length mode because that calculates the actual length of the spacing, not based on the parameter of the surface. because the parameter of the surface, the parameter space, can be skewed if the CVs of the surface are not spaced uniformly. So sometimes you might need the length. But as you can see, the software now became quite slow, and that's because we have a live preview that calculates at every frame the old pattern, and that becomes quite slow when you use length. So when you use length, it's advisable to use preview once if you have a lot of points like now, which creates a preview only when you ask for it and doesn't do it all the time. So you see now it's much faster. But let's stay on parameter and use live preview because it'll be easier to play with it. And as I was saying, we have now a uniform grid spaced uniformly. But we have here two ways to create fall-off effect on the spacing of the grid. And let's try the image first. We can create an image procedurally, so with the software creating it for us. And you can see I can act on the spacing of the surface. And it also goes a bit funky. Not so intuitive to understand how it works, but basically where it's white, the points will become more closer to each other. Where it's darker, they get spaced more. And you can create your own image by selecting a file as well. And otherwise there are different ways here to create procedural images. There's also like simple gradient maps, which are a bit easier to understand. So spaced on this side and it gets closer to that side. Let's go back to the normal Gaussian. Just to show you that you can use a different mode to invert the effect. So in this case, where it's darker, it gets closer, and when it's whiter, it gets further away. This is actually quite a nice effect. But the other way to do this is through graphs on each direction. So you can regulate the spacing along this direction, the U direction, and along this direction, the D direction. Sometimes it's a bit easier to understand this way. You activate it from there, so you select the mode with graphs and activate it from the ramp map, and then you have access to these graphs that you can see modify the grid to have different spacing. And there are different modalities. You can also use analytical. Maybe you can use this one for now. And then you can also use it in the other direction. And play with it. Or you can use your own NURBS curve. You can also add point. And you can also do it to rational, so create weight to get all the effects you want. But let's keep it analytical for now. Now, to give some extra controls, once you have found the right character of the curve, you can still work on the blend that the ramp had on the pattern. So there's a percentage, and you can decide how much of the ramp graph has effect on the pattern. So it's like a further control you can have on it. But once you're happy with anything you got, you can then bake it and get those points, which you will then have listed in the object lister. You can always hide them or even delete them. But for now, let's position an object with the distribute tool. We can import another file of an object we have created in Alias. Let's use this type of sphere. It'll take some time to open it. Then we have to select the grid, which will be listed. That will all be listed here. And let's preview once. You can see we have all these objects there. And at the moment, they are positioned as they were in Alias, so with the Z up. And that's okay, because we can orientate them to the normal of the surface. So now they just follow the surface direction. And we can also add the scaling to it. So first of all, we should probably start with a smaller scale of them, because they look quite big. And now again, we can create a scaling effect. In this case, maybe it's nice to use an image, just to do something random. We can decide to scale also in Z. So let's pick them so we can see them better. And let's export them. We save the result. So that we can see it in Alias. There you go. Well, we may decide that maybe it's better to get the negative rather than the positive of the sphere, and that should be an easy modification. So first of all, let's delete the current distribute. Let's hide this point. We can make the vector in Z negative so that we invert them. Or you could also just modify the module in Alias. We bake again. Let's delete one of them. And then we export again. Yeah, you can see we have all these negatives that we can now use in our model. to cut the surface. It probably take a long time because those are a lot of surfaces, but I hope you can see the advantage to have this software that can help you place all of those objects in ways that would have been impossible otherwise manually. I might do a calculation for you to see later. And here we have the final result. You can see the negative of the surface you were seeing before. Would be nice to add some fillet, but that of course will take a long time. So you can imagine that doing that manually is crazy, and usually even Dynamo will be actually hard to make it go across multiple surfaces this way. Instead in class Ajiro, have you seen this? It was relatively easy. Before I show you the grid with the finisher, I wanted to show you on these shapes the FreeForm Grid, because it works better on areas rather than unidirectional shapes. And I'll show you why. Let's add some tiles. So you see this type of grid has these two vectors, direction UV and UV again, that allows you to specify the direction in which the grid is flowing. So it's not anymore constrained to the direction the surfaces are flowing, but you can create your own direction. So as you can see, there's not the diamond option, because you can just by rotation obtain a diamond grid, but then it gives you the freedom to modify and obtain all sorts of different effects. You see, this kind of effect has a bit of a wavy feel to it. Yeah, you can just rotate it around. So usually it's not that ideal, because as you can see, it doesn't follow the border of the surface anymore, but sometimes it can be exactly what you need. And maybe we could now add a bit of a fading of the spacing through an image. See if this one takes us somewhere interesting. Maybe it's a bit too crazy. Maybe it needs more work. Oh yeah, you can also rotate it. But yeah, that was just to give you an idea of what can happen with that type of grid. Let's just apply an object to this one. We are going to see now another example with these more complicated patch layouts, and we can see around the corner, the upper corner, where the shape turns, that the surfaces are not completely aligned. One of the borders steps out from the flow of the previous surfaces, and that wouldn't work well with Ajiro. So we have to make them so that they are all aligned, even especially at the untrimmed level. So now we extract a curve to help us trim the above surface in a way that we can then convert it and have it aligned, as we said, with the previous surface. So at this point you will just trim convert, but now I have a file with this. I have a set of surfaces that were ready to be used in class Ajiro, and you can see that the flow of the CVs are all matching along the whole length of the surfaces. And now we can export these and import it in class Ajiro and start doing the pattern. We are now going to load our surfaces from the Alias Autodesk file. And remember that pressing X key, it will give you perspective. And if you press it again, it goes back to orthogonal view. And let's go and check the direction of our surfaces. So remember that the red direction should flow with the strip, with the surface strip. That's the U direction. At some point I will make this process automatic, so it will be enough to select the surfaces, but for now it's still manual. In the tool curve point division is actually automatic. For curves selection, it's the verse is automatic. So that should be all. We can now try to make a regular grid. Let's make it diamond. And I will say for now we better keep it with a low number so that we can place the object with more clarity. And then when we have a good disposition of the object, we can come back and add more tile. I'm gonna use a different module this time, which is this box. It's meant to be with radiuses, but since we're going to scale it, the radiuses will be skewed, so we'll leave it as a box like that. And it will need actually manual work if it needs to be less. Then we go to select our grid in Ajiro, and we can start to see a preview. And we realize that the box is far too big for our model. That shouldn't be a problem because we can always act on the scaling. But in this case, I think it is too much. Yeah, you see, the number will be too big for us to work nicely with it. So the best way is to create these modules on top of the geometry in which they have to be applied and make it a dimension that is kind of makes sense with the dimension of the surfaces you need to use. So let's paste the box here, and you see that it was far too big. And we try now to scale it to match a bit more our finisher. More or less, this is the kind of tile we were gonna get to go on our finisher. This makes more sense. Give it like this. Should be fine. Let's now re-import it with the scaled version in class Ajiro. So it is already following the normal of the surface, but it seems that is inverted. So you see the cap, it's actually at the opposite side of the surface, and that depends on the direction we choose for our surfaces, which gives the normal direction. But it is easy to fix, as we can just invert our model by changing the orientation of it. And now the cap is on top. Let's start to add some scaling. So you see we have scaling for every direction, and those directions are for the module universe. So that's why the module should always be following the main axis, because so we can scale it accordingly. And we can select the maximum scale and the minimum scale, and then affect over that range with our usual curves or images. Let's have a look. There you go. I probably exaggerated with the scale of the Z. We can increase it a little bit. And a little bit more. So automatically when we use the RAM scale, also the V direction gets a curve, which by default has this curvature. That's why you see smaller tiles on the borders and bigger in the middle. But what we want is more something like this, I think. We can now preview again. Okay, it's the wrong direction, and in that case we can change the curve or just select a different mode that would do basically the reverse. And there you go. So I think that now we have sort of a good direction, but you can see that the tiles are following always the direction the module was created with. which is kind of nice. It creates a different direction depending on the curvature of the surface. But we can also align the hue of our surface strip to one of the axes of the module. So by doing this, we can see now the difference, and this makes it perpendicular, so probably the Y is more appropriate. And now the tiles follow exactly the hue direction of the surfaces. Let's actually try to change the scaling, so we can make it that the X doesn't change and only the Y gets diluted. Yeah, you can see that in this case they get longer. The more the curve in our scale gets higher. So if we want the opposite, we could just invert the curve. But actually, I prefer the other way. So let's go back to this one. And make it a bit less exaggerated. Now let's go back to our grid. We can hide this current grid and make a new one. And we can also interact with the scaling of the spacing. We might need to do this. And on this side, we go for something in this direction. And now we go back to our distribute and change the grid that we are using and preview it again. Actually, I don't quite like the way this one is going down there. It seems too obvious. It's kind of nice what's happening there, but not at the bottom. So let's go back to our grid. We can maybe delete this one. I think this kind of move is much nicer, even for the spacing. Yeah. You can always experiment with the moves when you add more points to see what happens, because the behavior of the grid changes with even just with the number of points that you are going to add. Let's try like this. Now we're going to distribute once again, and we select the 21 grid. And let's try not to align it this time. I think it might be a bit more interesting. And of course now they are overlapping, so we shall go a bit lower with the Y direction. It's better, but also the X should be left. That's the nice way we can just interact and cover grids that we wouldn't have thought of initially. I think this can be quite nice already. It's just maybe too much space remains empty there. So we can leave this one as it is. So it's kind of saved. Let's hide this one, this current grid, and let's try to do a different one where we try to close that gap. With the NURBS curve, we probably have a bit more freedom to do whatever we want. You can even just use a linear here. So it appears that this side coincides with this border. So this is probably the best. Maybe we should change it and do it this way, since they're getting bigger at the back. There you go. Let's select a different grid. Yeah, I don't mind this one. I think we could do with a bit more points. And still make them closer. Let's bake it. Go back to our distribute and try preview. I don't like that those look too linear, too curvy, and they also follow the direction. So maybe we can change the direction here and see what happens. I think this makes it more interesting now. Well, let's try with the Y, aligning it to the Y direction. Yeah, I think this breaks a bit more the curve. Or we could just go back and change the change the grid once more, trying to find some different effect. But I'm quite happy with this, and we can see what it looks like. So we're going to bake it and import it in Alias, where we can have a better visualization of the situation. So this is something I tried before. I think actually it was a bit more successful. But let's now try and import what we've just achieved. That's the thing with Grid, you're a bit counterintuitive very often, so it's good to have a software that allows you to switch things up and discover the grid as you go. I think it's quite successful. There probably could be a bit more acceleration in the spacing in this direction, and maybe even in the sighting, but still it shows the kind of effect you can create with a multitude of objects laid down on a complex surface layout. The result is always quite satisfying, I think. Yeah, the previous one had more movement, more acceleration. There's one last thing I would like to discuss before we go. And it's probably better to see it with a regular grid. Yeah, you can see it there. I thought it would have been more apparent, but because of the way these TVs are placed in the model, as you can see, they are closer to the center to create a bit more of a acute angle, a bit more of an apex on this curvature. The CV spacing is not uniform, and that creates a kind of a skewing also on the grid when it's based on the parameterization of that surface. So you see, in this case, they are a bit more condensed in the center as the CV. Instead, if you do a length mode, you see that they relax because they're not anymore dependent on how accurate the uniformity of the CVs was. But that requires much more work from the software, and so it's often better to not use live preview in that case. It can be maybe a refinement when you have found a bit more of a happy grid. You can use length if that's the effect you want. And now, to conclude our video demonstration, we'll leave you with a little speed up clip of me going through the same process we have just seen on this part, but instead of using the ramp graphs, I will go to do the fadings with images. So also grayscale images where the white make the points get closer to each other, and whereas black spreads them further apart. I hope you enjoyed, and I'll probably post more than these tutorials in the future. Thanks for watching.